Alright, looking at one other new thing with triangles today, we're going to talk about classifying triangles. So they are used, or they are named by using their vertices. So in the following example, you would call this triangle ABC, which I think we already know. Similar to angles, we just use each vertex that is present. When we talk about opposite sides and angles, we're looking at the side opposite to an angle or the angle opposite to a side, so across from that angle or side. For instance, the side opposite to angle A would be side BC. Opposite to B, AC, and opposite to C, AB. Same thing with opposite angles. Looking at BC, angle A should be opposite, AC, angle B, and then AB, angle C. Okay. There are two different ways to classify triangles. You can either do this by their angles, which in that case we have right triangles, we have acute triangles, we have obtuse triangles, and then the last one is equiangular triangles, meaning that all their angle measures are the same. You can also classify them by the sides, which is probably something that you are semi-familiar with already. So we have equilateral triangles, where all sides are the same. Then we have isosceles, where two sides are the same. And we have scalene, where none of the sides are the same length. Okay. If we were looking in the figure, and I know it's kind of dark up here, so look on your paper, it's a little bit easier to see. An isosceles triangle has to have two congruent sides. So an example of this, where they're already marked congruent, would be triangle ABD. You could also use triangle BED, since these two down here are marked as congruent. A scalene triangle, an example of that, would be angle ABE, since none of those side lengths are the same. And an example of a right triangle would be ACD, since they have a right angle in there. These are obviously not the only ones that you could pick from, but those are one type of each, or one example of each. This example should look really familiar to you because we looked at several of these before earlier in the year when we talked about using the distance formula. So if you need a reminder, go ahead and write the distance formula on your paper now. We have D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug in our x and our y values for each one. We need to find the length of AB, we need to find the length of BC, and we also need to find the length of AC to identify what type of triangle this is. So from A to B, if we plug in our points, we have 3 minus 2 squared, and then 9 minus 2 squared. So this is going to be equal to the square root of 50. If we break that down in simplest radical form, it becomes 5 radical 2. Then for BC, if we plug our coordinates in, we have negative 5 minus 3. And then we have 3 minus 9. That becomes the square root of 100, which we all know is 10. So we can go ahead and reduce that. And then we've got the square root from A to C to find the distance. So negative 5 minus 2 squared plus 3 minus 2 squared. So square root of 50 once again, and that's equal to 5 radical 2. So to identify the type of the triangle here, these two sides are the same length and one is different, which makes this an isosceles triangle. As we said before, an isosceles triangle is a triangle with two congruent sides. The congruent sides are the legs of the triangle, so here and here, and the third side is called the base. The angles here at the base are their base angles, and then angle 3, where it's labeled up here, up at the top, is what represents the vertex angle. There is a theorem that goes with, or a couple of theorems that go with the isosceles triangles specifically. So it says if two sides of a triangle are congruent, then the angles opposite those sides must be congruent, which means that we know our base angles of an isosceles triangle must be congruent. So if we were to find the value of x in this example here, this angle at the top is 50 degrees. So this one is x, that means this one is also x. So 50 plus x is equal to 180, and then we can solve. 50 plus 2x equals 180, 2x equals 130, and divide, so x is going to be equal to 65 degrees. The second theorem says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So it's the opposite of what we just did. We're given these two angles are the same, so AB and AC must be the same. We can find the value of x once again by setting those two equal to each other. So 3x minus 7 is equal to x plus 15. Solving, you get 2x is equal to 22. So then x must be equal to 11. If you were asked to find the side lengths as well, you would just plug 11 back in. So you should get side lengths that are equal to 26. In this case, all they wanted you to find was x, but just be careful in reading your directions in the future. All right, in these next two examples, you are asked to find x and y, and then find m and n. Your y values are on either side here. Your x values are part of your angles. So if you can't see it very well, this angle up here is 50 degrees, and this one down here is 2x. So then I have 50 plus 2x. This one over here should also be 2x. That's equal to 180. Combine your like terms. So we have 4x is equal to 130, and divide by 4, so x is going to be equal to 32.5. Then in solving for y, we just set those two numbers equal to each other. So 3y minus 10 is equal to 8y minus 30. We have 20 is equal to 5y, and y is then equal to 4. With m and n, we know that this angle is 5m, n is up here, and these two angles are congruent. So we need to know what this angle is first because we have a little bit more information in this triangle over here. This bottom angle is 40 degrees, then we have a 90-degree angle. So if I add 90 plus 40 plus x, I should get 180, which should mean that x is equal to 50. So if that is 50 degrees, then this angle down here also must be 50 degrees. From there, then I know that these two things must be the same. So 5m is equal to 50, which makes m equal to 10. And then you have 50 plus n is equal to 180. So n has to be equal to 80. And there's your two solutions. we have some properties with equilateral triangles. So there's a couple of corollaries with them as well. A triangle is equilateral if and only if it is equiangular. Therefore, if all the sides are the same length, all the angles must be the same length, or all the angles must be the same measure. If all the angles are the same measure, then all the sides must be the same length. Each angle of an equilateral triangle is going to measure 60 degrees, because if all the angles are the same measure, you divide 180 by 3 and get 60. Here, if you're asked to find x and y, you know that these two things must be the same. So you have 3x minus 1 is equal to 4x minus 12. That makes x equal to 11. And your y values, you have 3 times 4y is equal to 180 over here. So then 12y equals 180, and y is equal to 15. So with this next example, you know that GHJ is isosceles, and angle G is the vertex angle. So we're going to draw this out where G is at the top. That makes H and J your base angles. GH is equal to x plus 7, and GJ is equal to 3x minus 5. You know that these two things have to be the same, so set those two equal to each other. X plus 7 is equal to 3x minus 5. That makes 12 equal to 2x, and then x is equal to 6. So GH is equal to 6 plus 7, which is 13. GJ is the same length, so it's 13. And then HJ was equal to x minus 1. So then we are going to take 6 minus 1, and that's equal to 5. So I would like for you to work this next one on your own, and then come back and check your answer. Okay, we know that triangle MPN is equilateral, so that means all of the sides have to be the same. Pick two of them that you're given and set them equal to each other. So MN is 3x minus 6. MP is equal to x plus 4. Solve for x. So you get 2x equals 10, then x is equal to 5. Now it asks you to find the measure of each side of the triangle, so plug it back in. 5 plus 4 is 9. 5 times 3 minus 6 is 9, and so is 2 times 5 minus 1.